The following example serves to show what Rolle's theorem states. Well, it states that we have a function f of x, so we're going to take a look at the graph of f of x, and some conditions for this theorem. Well, it's going to be defined on a closed interval between a and b, so let's write this down. Alright. We might see this also in interval notation, so that's important to note. Okay. So the function is defined between a and b. Now, to meet the conditions, our theorem states that f of a equals f of b, which equals 0. So let's put 2 points on our graph here. Suppose that this is a, and this is b right here. And they're both equal to 0. So the function goes through a and b. It is continuous throughout and differentiable between the open interval between a and b, not inclusive. So continuous in this area. Okay, everything in between is continuous throughout, and differentiable between these between a and b, not inclusive, of course. So the function might look a little bit something like this. Okay, and the assertion is that there's some point right in between. So let's put a point somewhere in between here. Suppose it's somewhere right here in the middle, and that point is a C, Greek letter C, and where the slope of the tangent at that point is horizontal or 0. So something like this right there. Formally, I mean, since this is the slope of a tangent, we can formally say then f prime of that C equals 0. Which makes sense, since the graph goes from A to B. There must be a point where our graph changes its direction. So this is what Rolle's theorem is trying to say, and it's a very brief explanation of its meaning.
Made with Doodlecast Pro.